Hello and welcome to all the kids and parents watching. I'm really glad to have you all here attend this session, and I hope you guys are doing well, staying home and safe. Now, this session is a masterclass on facial recognition using AI. Now, a lot of kids have been staying indoors for quite a long time now, and you might be a little bored. So this masterclass hopefully will trigger your brains and generate some amount of curiosity in you. Now, this masterclass is the first of its kind, unlike our other masterclasses, which are aimed at a much older audience. This one is for students who are of classes 8 to 12. And this masterclass will be slightly informal. And we hope to do more of these sessions with you guys. And so there's a quick feedback form in the description that you can quickly fill up after the session. All right, so let's begin. The intended audience is students of class 8 to 12, but however, anyone can watch the session and I assure you that you will learn something out of it. All right, so sit tight and enjoy the session. To quickly see how many of you are being completely attentive in the session, I have a quick question for you. What was Tony Stark's artificial intelligence assistant in the Avengers Infinity War? I'll give you a couple of seconds to write down the answers in the YouTube comment section. And all right, I see a couple of people answering Jarvis and a couple of people answering Friday. So people who are answering, thank you for being attentive to the session, and people who have answered Friday, you got it right. You are the true fans of Marvel. All right, so I want you guys to keep this attention level throughout the session, and we'll have a great time together. So for our broader agenda for this session is that we will be discussing two things, artificial intelligence and facial recognition. And by we, I mean Mohita and I. To be a little bit more specific with the agenda, I will be discussing what is artificial intelligence, a few of its applications, and then we'll move on to what are images and how do computers look at images, what images mean to a computer. And Mohita?
Hi all, I'm Mohita and I'll be taking you through the face recognition part.
All right. So now that we have our main course set, you know what you guys, you know what you expect in the session. So let's begin. So you guys might have heard these terms, artificial intelligence and machine learning and smart devices, smart homes, smartphones, smart this and smart that. So a lot of people, when they hear these buzzy, clickbaity words, a lot of people have in their mind something like a superhuman robot like Titty or Ultron, which is quite common, including me. That's what I thought the first time when I heard these words. But these robots, super intelligent robots, are quite far from current reality. They're not really, they are AI technically, but they're not a reality, not yet at least. So what really is AI in the current scenario? To give a textbook definition first, artificial intelligence is intelligence demonstrated by machines in contrast to natural intelligence displayed by humans and animals. When the first calculators were invented, some people called that artificial intelligence because they can do very complicated calculations very quickly. And some people considered that as intelligence. But to be clear, they are not really intelligent. All they do is follow a set of rules. You give the calculator rules for multiplication. So it multiplies 10 times 10 and it gives you 100. The rules never change, the answers never change. So there's nothing new that a calculator learns, or there's no new response that a calculator gives. It just follows a set of rules. This is called hard-coded machine. It is coded what to do and it does that for the rest of its life. But intelligence is something different. Intelligence is the ability to acquire knowledge and skills and apply them. For example, you play basketball. So When you play basketball, either you defend or you go on offense. Every move that you make is you acting out of your intelligence. You dribble a ball, you are acting out of your intelligence because you have learned how to dribble a ball. Your muscles have been trained how to dribble a ball without letting it go. This is a sign of intelligence. Now, having said that, even machines can be taught how to be intelligent. Now, machines cannot be taught how to treat, treat play a basketball yet. We don't have robots for that. It is possible, but we don't have them yet. But we do have machines that can do intelligent stuff like driving a car. Driving a car takes a lot of intelligence because continuously you need to grasp inputs from the environment and also respond to the inputs by changing the way you behave. So, for example, if a car ahead of you slows down, you observe that, you notice that, you digest that information, and you immediately respond by slowing down your car. All right. So this is one extreme example of artificial intelligence. This is the state of the art of artificial intelligence, self-driving cars. And the way we try to teach machines how to drive a car or how to do this or how to do that, when we try to teach something to a machine, we call that training. And in a broader sense, we call that machine learning because the machine is learning something based on data, based on your inputs, and based on what you tell the machine. You give an input to a machine and you tell it what you expect from it. So it eventually learns from that. So this is a common term called machine learning, where you give a machine enough information to learn from, and the machine learns from it. It is something like a baby trying to walk for the first time. So when a baby tries to walk for the first time, it has all the strength in its muscles to walk, but it does not have the experience to walk. Its muscles are not trained on walking. All it does is fall a couple of times, multiple times, and eventually at some point its muscles get trained enough that it starts walking again. So to walk, it takes a couple of more experience. It has to know how to balance its weight from and transfer its weight from one foot to the other. And this form of learning from experience is, as we discussed, machine learning. And there is something called as a machine learning algorithm, which lets the machine learn in a very specific way. So to understand what we're talking about, machine learning algorithm, that's quite a scary sentence. To give you a little bit more context and more of a concrete example, I want you to take a look at this picture and please tell me let's consider this picture as data. And this data has multiple animals. Let's call those animals data points. We have zebras and we have wildebeest. Let's just call them buffaloes for simplicity. We have this data, which is the picture. We have the data points, which are the animals. I want you to guess, based on this data, what animal could be under the green patch. Take a couple of seconds to answer that question. All right. So a lot of people have possibly answered that it's a buffalo and not a zebra. And similarly, I want you to answer what is the animal in the second, the red, under the red patch. Take a couple of seconds to answer that. Right. Under the red patch, we have a zebra, and it is pretty obvious so far uh, that it's a zebra. Now, I want you guys to guess what is under the blue patch. Take a couple of seconds to answer that. All right. A lot of people might have answered that the third animal, the animal under the blue patch, is a buffalo, but turns out it's a zebra. Let's take a step back and acknowledge what we've just done. So we had this data, we had the data points. In the first instance, we didn't know what this animal was, but we did guess it right because the surrounding animals were buffaloes. So we guessed it that it's a buffalo. In the second case, we had zebras surrounding this animal. And we were right in guessing that this animal is a zebra. But in the third case, we have buffalo surrounding them. And with the same logic, this logic that the nearest animal could be the best guess that you can come up with, you guess that this animal is a buffalo, but turns out it's a zebra. But what if I had given you this information before? Would you have still answered that the animal under the blue patch was a zebra? I mean, was a buffalo? No, after looking at the new information, you would have guessed that the animal under the blue patch is a zebra because now you have more information, you have more context. Now you see that the animals closest to the unknown blue patch animal is a zebra, and the closest animals are zebras and not buffaloes. So this is something machines can also do. You can give the machine data. You can give the same data to a machine. You can tell the machine that these are the data points, these are the animals. This animal, this data point, this animal is a zebra, and this animal is a buffalo. Now tell me what is this unknown animal that's under the green patch. And the machine can tell you just like you, and it will get it right that it's a buffalo. Similarly, in the second case, and similarly, in the third case, just like you, the machine will also get it wrong because even the machine didn't have enough context. Even the machine thinks that the closest animal is a buffalo, and hence this animal also could be a buffalo until it gets new information and you update the belief and you update your answers. This way of updating your beliefs and updating your answers based on new information is nothing but machine learning. And the way you do it with the logic that you use the logic that the closest neighbors are the best guess to guess the unknown animal. This logic is called an algorithm. So this whole thing, what we've done is we've demonstrated a machine learning algorithm. And the process of doing that is machine learning. And by doing this, you can get two systems that are intelligent. You can have systems behave intelligently. Okay, now we've seen what we can do with this. So machines can learn from data. We've seen that. We saw machines can tell that it's a buffalo or it's a zebra. But what can really machines do? Can it do something very useful? How can telling zebras apart from buffaloes be useful? Can that be really useful? So it turns out machine learning is quite useful in detecting cancer, in detecting earthquakes, and in detecting aeroplane machinery faults. So just like before, in the case of cancer, you have cells that are cancerous and you have cells that are normal and healthy. And you want to know which cells are cancerous and which cells are healthy. And if there are a good amount of cancerous cells, you can detect the stage at which that person is in his cancer. So this machine learning, but the algorithm that you use here will be slightly different. There, in the earlier example with the zebras and buffaloes, you use the logic where the closest animal to the unknown animal will be the best guess that you have. In this case, it will be slightly different. Will have different algorithms. So we have different algorithms for different type of problems and different type of data. Now, in the second case, even here, machines can detect an earthquake much earlier than they occur, which is a very good thing because you would want to be prepared much before an earthquake hits. And the sensors are not only depending on sensor data like seismic waves and all of that can be useful, but it is only until the last minute that you notice any change, and it will be too late until you know that something's going to hit you. But using machine learning, you can predict when is that going to happen because a machine can tell you the difference between a normal day and a day and a couple of days ahead of the earthquake, that something is changing. So it can tell the difference, just like it tells the difference between zebras and buffaloes and cancer cells and non-cancer cells. It can tell the difference between normal days and potentially earthquake days. The same with aeroplanes. So before a component or some piece of machinery actually completely fails, machine can detect it well in advance. So you give the machine data like this is the aeroplane, this is the machinery, and this is how it should look when it's healthy, and this is what happens when there's a fault in the machine. So the system can learn that when there's a fault, this is how it behaves. So when it observes that behavior, even before the fault actually happens, you can detect a fault in the machinery of an aeroplane. And that saves a lot of time for the engineers and a lot of lives, which are on the hands of the pilots. All right, these are some very useful, very important, and very interesting applications of artificial intelligence and machine learning in general. But also, there are a few fun things you can do with machine learning. Something like this. So this is an interesting application of machine learning. This is specific to faces. So we can use machine learning on faces in a certain way that can tell the machine learning that this is a face. It can tell the algorithm this is a face, and these are the eyes. And whenever you see these eyes, you put these glasses on those eyes. Similarly, when you see the hair and the head, you put that cap on the head. So that's how you train a machine learning algorithm. And this is one of the applications that you can play with. Similarly, you can use machine learning to, instead of just playing with the images this way, adding new elements, you can entirely transform an image from this to something like this. So this image of me is made into an image of something looks like a much older person. And this is done using a little bit more advanced techniques of artificial intelligence. Now, these are specific to faces, the one we've seen earlier and this one. And then there's also a very popular application of machine learning on faces, which is face recognition, which is our core of the session today. In this picture, what you're seeing is a bunch of celebrities, and we have little green boxes around them. And each of these green boxes tell that there is a face there. So machine has been able to properly identify that this is a face, this is a face, this is a face, but the machine missed out identifying this face, maybe because it is half covered and even this face. So it's not completely perfect, but it gets there eventually by failing and failing, and eventually it gets to a certain point where it can do a good job at what we want it to do. Now, in this case, instead of just identifying that there's a face there, it also has names below it. So machine can recognize these people, because we would have earlier trained the machine with this telling that this is a face and this is the person to whom this face belongs to. And this is how the machine learns to detect faces and also recognize them. We'll get into a bit more detailed discussion on this, and until then you can also see that machine gets the recognition wrong. So in this case, this is Meryl Streep, but the machine identifies it as Ellen. Maybe that's reasonable because they have quite similar features. And we have red boxes, which means that machine is not completely confident whose face it is, but still it has given some name. So anyway, so up until here, we've seen that machines can learn from data, and there are good important applications. There are some fun applications, and there is also this. So facial recognition. We'll see a little bit of what applications we have about facial recognition and how useful they are a little bit later. But before that, let's discuss a little bit more on images. So what we've learned so far, park that aside for a while, and let's just come with a fresh mind and think about images. So what are images? Images can be thought of as a representation of something. It could be living things, it could be objects, it could be anything. It could be your imagination or anything. Anything can be an image. Now, one way to think of images is as storing information. So if you can look at this image, you have all of this information here. the pumpkin, the red color, the yellow color of the pumpkin, the texture of the pumpkin, the shape of the pumpkin, the size of the pumpkin, and similarly all of these other objects, the Oreo, the leaves, the tea, the cup, the saucer, everything. So all of this information can be stored in this image in this way. So once you look at this image, you can get an idea of what the objects are. You can guess what the texture is like. You can guess what the Oreo feels like in a way because you've also had experience with it. So images can store information like this. And since we've been storing information, we've stored information on paper by drawing, we stored information on canvas by painting. So we've done all of that, but there's one interesting thing, the way computers store information. So there's something interesting that computers do to understand images. So for a computer to look at an image and to store an image has to be broken down into something called as pixels. So this is how the computer looks at an image. The computer looks at an image as a big box made up of tiny little boxes. And these tiny boxes, we'll call them pixels. So each pixel, so each box, inside each box, you have a number. And this number tells us the brightness level of that pixel. So in this case, we have one color in the image, and that is gray. So we have dark gray, we have light gray. So if we look at the pixel values, that is the numbers inside those small boxes, this area, the pixel values will be higher. And this area, the pixel values will be lower. Similarly, there's a slightly different way color images are represented. Instead of having a single big box, you have three boxes for each of the three primary colors. So this is how an image is seen by a computer as pixel values. And there are some good advantages to have images being represented by numbers. And the advantage is that numbers can be played around with. You can add numbers, you can subtract numbers, you can multiply numbers. And when you do all of those things, you can change the how images look entirely. Now, this is a normal image taken on a Saturday evening. And this image, this is the same image, but the numbers have been slightly changed. A constant value has been added to the whole big box. Like, let's call that big box a matrix. All right. So this matrix has numbers. And if you add a number to all of the numbers in that matrix, it brightens the image. Similarly, you do another different operation, you can change the color of the image. It was colored earlier, now it is black and white. Similarly, you can do a little bit more advanced operations on images, and you can get to effects like these. You can see that there's a glowy effect on this image. So all of your Facebook and Snapchat and Instagram filters that have all sorts of face filters where you can have vintage look, you can have this look, you can have that look, you can have beautify look, and all of that is possible because images are being represented as numbers. And since they are numbers, we can start doing mathematics with them, and which is very interesting. Only playing with these numbers, just adding subtraction and multiplication in a certain way changes the image entirely, as we've also seen earlier. A normal looking image can be turned into something of an older guy. And that's really a very cool application, and it's fun to have such sort of things. So let's pause for a moment. Let's see what we've learned so far. We've learned the definition of artificial intelligence, what is intelligence and what is not. A calculator is artificial and machine, but it's not intelligent because it is based on rules. We've seen that a self-driving car, a car run by a software, is intelligent because it has to respond to environment. That is, it gets new data and it updates the way it behaves. That is intelligence. And we've seen how to get a machine to behave intelligently. That is through machine learning. There are a couple of other ways, but let's now stick with machine learning, and which is the most popular and the best way to do it so far. So we've seen that we can give computer data. We can tell it that this data belongs to a certain animal, this belongs to a different animal. Tell me what this new animal is. the computer, you give it instructions how to figure out. You tell it that the based on the nearest animals, guess this one, and that we call that as a machine learning algorithm. And this whole thing where the computer learns to identify new animals based on new data as training. So we've seen three important terms: AI, machine learning, and also training. We've seen how it learns from data, as I said, which is training. And we've also touched upon how images are stored in a computer and how they are seen by a computer, and why it is necessary, why it is important, and how it is very useful to represent images as numbers in a grid of pixels, a big box with tiny boxes called pixels. Now, with this foundation, we are quite ready to get into the advanced stuff, that is facial recognition, which is one very important application of artificial intelligence. And we'll also see why facial recognition is important and how we can use facial recognition in different contexts in a bit. So from here on, I give it to Mohita. So thank you for listening so far, and carry on. Hi, Mohita.
Thanks, Prithvi. So I'll be sharing my screen now. So hi all, I hope you have been able to follow the session so far. But now we are going to get into this face recognition. So as Prithvi shown before, that face recognition is simply nothing but recognizing a face in an image. It not only tells that this is a face, but it also shows that whose face is it. Before we go into understanding that how face recognition works, let's first understand that what are the cool applications of this. So one of the major and very important applications which we see around these days is how police organizations are using this technology to identify criminals. They can use this technology to find out criminals in a crowd, in public places by using these camera feeds. And using this, they were able to actually catch many criminals so far. The other cool application of this face recognition is how you can unlock your phone using this technology. Many of you would have seen Apple's Face ID, where you actually just show your face and it unlocks the phone by recognizing your face. Another application is in Facebook. So I'm assuming that many of you will have Facebook accounts, and you would have seen that it's asking you to tag either your friends or yourself by giving suggestions of the names. So at the background, what it is using is this facial recognition technology. There are many schools and colleges where this technique is being used to auto update your attendance. Think of a scenario where you walk into your school or college and your face gets recognized and it automatically updates your attendance, and you can just move on and start to learn things just by going inside the class. So by now, you would have understood that face recognition can be used at many places. In fact, it can be everywhere and anywhere. So we have seen how useful this technology can be. So first, now let's understand that how it actually works. Before getting into the facial part of it, first let's understand that in an image, if there are a lot of objects, as Prithvi said, that images consist of many objects like different backgrounds, different people, different things, then first what it needs to do is to detect the faces. So the first step in recognizing a face is first to detect that there is a face. So if there are many faces in an image, then first you need to actually detect the faces. Then you will go on and analyzing faces and try to recognize it. So let's see how it can work. On my screen, you can see two images. and both of these images are of same person. Now, as a human, we have innate ability to recognize a face, even if we have met a person once in our life and we are meeting the person second time in a very different scenario, in different orientation. The person has changed his or her hairstyle. They are wearing specs, they are not wearing specs, or they have even made some changes in their face. Still, we have this capacity to recognize faces in such a unique and brilliant way. But for a machine, this task is very complex. As Prithvi shown you that an image is consisted of pixels and of numbers. So if you think from that concept, then both of these two images will have different numbers. And for a computer, these two images will be completely different. So how do you think that a computer can learn to understand that these two images and the faces in these two images are of same person? Because in one of the picture, the brightness is more, in one it is less. In one of the picture, I have specs, but in one I don't have. And also the orientation and the shape of my face is a little different in both of the pictures. So we actually need to think of more specific things in a face in order for a computer to read a face from. So there we will actually get into a concept of facial features. What these are is, these are very specific key points of a features of a face, like the distance between the eyes, the distance between the nose and the lips, the shape of the jaw, the depth of your eyes, and so on and so forth. Because every face will have eyes, nose, and lips, but these key features, very specific key features, will actually make your face different than the other face. A computer actually can take such hundreds and thousands of features and collect it and make a print out of it. You can imagine it to be like a face print. You would already be knowing about the concept of fingerprints. So in the similar way, you can think that a computer looks at a face and it creates a structure like that of a face print by using all those different key points. But now think about it. How you actually teach a machine to recognize that whose face print it is. We need to get smart about it. One idea is to feed the machine with lots and lots of data of a person in different orientations, shapes, sizes, different lighting, and even at different ages. But doing this is a very difficult task because anytime a new face comes, again we need to collect hundreds and thousands such samples and feed the computer with it. And even in such cases, there is a possibility that a computer or a machine will not be able to recognize you. So we need to get even more smarter about it and teach computer or machine in a very different way. What is this new way? So we actually will teach the machine to understand that what makes two faces similar, and what makes them different. So for that, what we will do is, we will feed in the three samples of an image of images where two faces are of the same person and the third face is of a different person. And we will tell the machine that yes, these two faces are of same people and these two faces are of different people. In this slide, you can see that the left person and the middle person is of same person, is the image of same person. But the image which is in right and the image which is in middle are of different person. So if we keep on giving such examples to the machine, what it will do is, it will start to understand the patterns which makes two faces similar and two faces dissimilar. And it will create a network of faces in an n-dimensional space where it will keep the most similar faces in one side, and it will keep the dissimilar faces on the farther side. So I'll just repeat what I said. It will create a network of faces in an n-dimensional space where similar faces will come closer to each other and dissimilar faces will go farther from that. Now, when we actually take a new photo of a person and feed it into this machine, which has just learned lot these patterns of similar and dissimilar faces, what it will create is a pattern of this new face and try to match it with all the other available patterns inside its network. And then whatever pattern it find it most similar to, it will give us the recognition of that face. So this whole process can be uh, summarized in this step-by-step way. One, we have an input image, which can have many objects, many different faces, in different orientation, and different lighting. So first of all, what we actually need to do is to detect the faces. So it's just right now we are just finding out that this is a face and get a face print out of it. The face printers consist of those hundreds and thousands of key features of and very unique and special key features of your face. Once we have got these face print, we will feed this print to this network, and this network will create a pattern of looking at all these features, and by whatever it has learned through all those samples of similar and dissimilar faces. So the pattern which this network will give us will use this pattern to do a face match, where it will try to identify the most similar face to that pattern and give us the recognition. So I hope that you understood the process. I'll just repeat it once more, that we will get a input image, detect the face inside it, get a face print out of it, feed it to this AI network, get the pattern out, and try to find a match. That's how this whole thing works. Now, you would be knowing that all these new big tech companies like Google, Apple, Facebook, Amazon, Microsoft are using this technology in many different phases. They are having many products and features which gives brilliant use of these technologies. The reason why they have such an awesome technology is because they have enormous amount of data, which can make these systems so powerful that they can even beat humans sometimes. We are actually going to see such applications created by Amazon, and we will see a demo of these applications. So the application we will be discussing about is celebrity recognition and face comparison. So I hope that you were able to follow so far, and I'll take you to these demo. So I will go to a browser and check for this service which I have account on. So the service is called face recognition, and I'll click on this, and I would need to either sign in if I'm already not signed in. So let's sign in once. So I have already given my user email address. Now I'll just type in my password to sign in into this. So you can see that I am on this product which is given by Amazon, and I'll open this application, celebrity recognition. So in this application, what will happen is we will give it a face of a celebrity, and it will give us our answer of that which celebrity it is. So let's try it out. So I will give it a photo of a celebrity, and let's see what answer it gives. So I have uploaded a photo of Hrithik Roshan. I am sure you all would be knowing him. And it gives us the output of the name Hrithik Roshan, which is correct. Let's try out a few more examples of these. I'll drag and drop another celebrity's image and see that what our answer it gives us. So as you can see, it has correctly identified this person as Prabhudeva. So now you can understand that these applications can actually perform very well and give us the right output of a person who is known. So here, important point to know is that these systems have been trained in millions of such images to understand the patterns of the faces and actually then able to correctly identify it. Let's check out another application here. It is of face comparison. So what I'll do is I'll upload two faces, one my face and another face also which is mine, and see what it shows us. So you can see here that both of these faces are similar. What this application is showing is that both of these are equal, and it is 99.5% confident about it. Now let's try out with two faces which are of two different persons. So here I'll upload an image which is of a different person. And you can see here that it has told that this face is not actually equal to this face. How amazing is that? Even though both of these faces have open hair, little smile, and even the lip faces and nose, all these points are very similar, still it is able to correctly identify that these two faces are not same. Let's try out one more interesting thing. Because we know that these machines have been learning the patterns of faces a lot, let's see how it can actually do a facial analysis and show us something about our face. So what I'll do is I'll upload my photo and see what it tells me about this. So you can see that it shows all this information about my face. It says first that it looks like a face. It appears to be a female. It also tells the age range, which is 12 to 22 years old, which is not quite right, but still it is closer to where I am. It says that I'm smiling, it appears to be happy, and also it is not wearing glasses. So how cool is this that it can give you so much information about a face by just uploading the image to a face. Now actually these I have never given my face as a training, but it is still able to do all these analysis and show me all this information. So I hope that you were able to relate all these things to what we have learned so far. So let's get back to our presentation now and see what other things are there for this technology. So far we have seen all the great applications and of face recognition, understood how it works, how it learns, how it recognizes patterns, and how it actually identifies a person. But with every technology, there are also some drawbacks. We also need to understand those drawbacks. One of the major challenge and disadvantage of this technology is privacy violation. Because these systems are trained on data, for making these systems, you are giving lots and lots of your data and information, which can be some of your personal information or public information. It actually gives any person the ability to hack this system and make very wrong use of this information. In China, they have made a system where actually they provide a score to a person by using this technology. So they are actually tracking a person wherever he is going, whatever he is doing, and based on that, they are providing a score to that person. If he does something good, it provides a positive score. If he does something wrong, then it gives a negative score. Now think about such a situation. If that you are being tracked everywhere and you cannot do anything anonymously, how big of a challenge this is to our privacy. So we need to be very cautious about this part. The another challenge which this technology takes with us is the biasness. What you mean by biasness is that it sometimes behaves very differently for some types of examples and very differently for another type of examples. Like there were many instances where this technology was incorrectly identifying all black Asian women, black African women, but it was correctly identifying all white men and white women. So we can see that it's a clear indication that these systems have not learned enough about the black Asian women. What can be the reason behind it that we have not given it as enough examples of black women, but it still gives a it creates a question that how reliable these system can be. The another challenge is accuracy. These, in most of the cases, they perform accurately, but there are cases where they perform inaccurately, and that can lead to misidentification. You would be knowing that AI system can very easily be fooled. If you put on a patch on your face or you make some strange distortion to your face, like what it is shown here, there is a high possibility that it will recognize you incorrectly. There can be an issue of mistaken identity. You would have maybe seen movies about it, but this is a real issue. So, because of all these challenges, there are many places where these applications are either banned or they are being used in a very controlled manner. And it's important that you understand that. So, if I think about the future of the face recognition, even though we have lots and lots of challenges here, we also have more than those benefits of it. It can be used in travel, it can be used in banks, it can be used across a government to smoothen out many operations and many activities. You can just walk into a place and get recognized, and all your information is available, and it will reduce all the time and efforts which are going in just storing and keeping that data. But also we need to be very cautious and about how how to use these technologies proper and train them in a better way. So that's actually the task for you guys to make very smart technology and algorithms which can overcome all these challenges and create some really very cool applications which can be very beneficial to human race. I won't be amazed if many of you would have already gone through airports and done some check-in processes which are using these technologies. It just look at your face and in 5 or 10 seconds you are checked in into a flight. If you have not come across such things, I am hoping that it will happen very soon to you. After knowing all about the facial recognition, how it works, where it can be used, I am very interested in knowing that where would you like to use facial recognition? You can put down your comments in the YouTube section, and I would be very happy to know that what ideas you have in your mind. And also, as Prithvi mentioned in the beginning, that we would be sharing a form soon, which you can fill up and tell us that if you like this session and what other type of session you want to have in future. It will help us, building such more such sessions for you. Hope you enjoyed it and learned a lot through this session. Be safe and stay at home. And thank you very much. Now we will be taking some questions from you guys, and we will be answering those. So let me look at some of the questions you guys have, and I and Prithvi can answer that.
Amrita, can you take that up? Can you detect coronavirus with these?
Okay, so that's a interesting question and very uh, very relevant question. If I understood the question correct, it is saying that can you detect corona? I don't know what BSB means, but uh, if we actually train the model to find the differences between the people who has corona and who doesn't have corona, there is a possibility that we will be able to detect that who is having corona if we give a new face to it. So that's very much possible. That is what I have to say about this. Another question is that can we identify twins using these application? That's an interesting question, and there has been a lot of research which has been going on. In Apple, there are a lot of tests have been done. Some of the tests have failed, and some of them have passed as well. But it's actually very difficult to identify twins just by using this technology. Maybe in future we will have more sophisticated algorithms which can actually even take the texture of your skin and add additional identifiers like the distance between the pores of the faces, and maybe it will help identify twins very correctly. But so far I don't think that it is able to identify twins very correctly recently, and it is developing across. Currently, maybe along with facial recognition, other technologies are mixed with this to identify twins, identical twins. Prithvi, you want to take up the next question?
Right. This question is, what are the best programming languages to learn to get to understand machine learning? So popularly, earlier when it was in its early days, people have used MATLAB until 2011-12. But right now, the best and easiest way to get into machine learning is by learning Python. We have matured libraries and everything to get your models running without having to code everything from the scratch. So yeah, Python is your should be your favorite language to go to for machine learning.
Okay, another question which I can see is that can we use this application to identify criminals? So actually, I have given an example of this, and yes, we can do use that, and in US and in many other countries, it's being used already. So yes, we can identify criminals, but we need to be very cautious about the fact that if if they give us incorrect result in some cases, then how do we train them even better that uh, any no innocent person can get recognized as a criminal? Another question is, uh, what programming language can you use to do face recognition from the scratch? So you can do it in many programming languages because it's just building an algorithm. But my favorite would always be Python because it has uh, all the uh, all the processes, the libraries, the functions are very well defined and very well structured to do such an application at scale. So my favorite language to do to do this from scratch will always be Python, but you can do it in Java, you can do it in MATLAB, and any other programming language. Okay, so Nandini asked us that can you tell us that any other facial recognition software? Yeah, so Nandini, many companies and startups are giving lots of softwares who can do facial recognition, and these are actually available in market to be used by anybody. Uh, uh, in the bigger companies, all Google, uh, Microsoft have softwares like facial recognition who can just you can just plug in those applications to your software and start using them. Another question is, can you tell us other facial recognition application? Okay, so let me think about it. There are many, but one more interesting application is actually that once you come to your phone or you go to a mall, they actually show you advertisement based on by recognizing your face. It's just like how you actually go on shopping on Amazon and Flipkart website, and they give you examples which are very relevant to you. In the similar way, they can actually recognize your face and give you the examples which will be liked best by you. So I think it's already used in many countries that you walk in a mall and the advertisement and the picture changes once as you align your face to that poster. So this is also one of the cool application which is there.
One question is Hardeep Kaur asks, can I use my own pic for facial recognition? And isn't that a security issue? It is quite a security issue. There are many misuses of using facial recognition technology, as in China, they use facial recognition to track people, as you heard before during the presentation. There are privacy issues, of course, but you can also have very specific applications with facial recognition where you do not have to worry about your privacy. Like, let's say in a classroom setting, you want the attendance to be noted down without you having to call your number or without the teacher having to manually call out you. So in that case, just by looking at your face, the camera registers that this person has attended the class, and this data can remain local. So it doesn't have there is not much of a privacy breach. So it is risky, but it's a technology. There's two ways to go about it. Either you use it or you misuse it. Yeah.
Okay,
And another
so
question is, yeah, which one has better future, NLP or CV? So both are quite important. Both are equally, I might say, important. They have very different applications. Uh, yeah, I mean, for a career perspective, currently there are way too many NLP jobs compared to CV jobs because computer vision takes a lot more resources than audio or text. Yeah, both are equally important. Both have big, huge potentials to achieve a lot of things. There are good applications, there are important applications in both of them. Yeah.
okay, so the next question I would take is of Kritika's. So she asked that is face recognition used in Lenskart website. So Kritika, when I have last checked in, they don't actually use face recognition, they use face detection. So it only detects your face, that there is a face here, and then it gives you the aspects to wear and all. It is not going to tell that you are Mohita and it is your face, but it is only going to tell that this is the boundary of your face and here you are wearing specs. Okay, so I think this is it for this session. We would love to know if you have liked this session, and if you want to know if you want to have more such sessions in the future. Let us know in comments, and also you can fill up that form. Thank you very much.
Thank you, guys. Bye.